Hi, in this video I would like to show you how to run machine learning algorithm on Android device to recognize objects. We are going to use TensorFlow framework from Google and test the model on Zebra Android device. More specific, I will train the model using Windows 7 PC and then transfer this model to ZebraTC51 for testing. The motivation of this work is to prove whether the TensorFlow application can work on the modern Android mobile architecture. Of course, we are going to check only the testing phase on the mobile device. Our goal, however, in the future should be to enable both training and testing on the mobile device. Should be done in one application. But because of computation complexity of training and lack of frameworks on Android, it is not yet possible. I'm going to follow two tutorials called TensorFlow for Poets 1 and 2, written by Pete Warden. How to achieve this goal? First, we need to download the TensorFlow framework from Google. Having installed the framework with all dependencies, we will copy the model from the TensorFlow for Poets tutorial and then retrain this model, the existing model, to fit to our images. And at last, we will transfer the trained model to the Android application on Zebra device and then test it live to check how good the classification is. Installing the TensorFlow framework for Windows is quite well described under the link shown below. I checked, however, several TensorFlow installation methods for Windows, and the one working for me was using Anaconda distributions. First, I installed Conda 4318 for Windows, and then in Conda, I installed Python 353, of course, because I wanted to profit from my NVIDIA GPU. I had to install also CUDA Toolkit 8, NVIDIA drivers, and CUDA Deep Neural Network Library 6.1. So finally, having done all this preparation work, I installed the TensorFlow 1.0 with the GPU support. This installation worked well, and training was done on my GPU NVIDIA M2000M, which has 4 GB video memory. So this is how my PC looks like. It has all these software elements I mentioned before, and on top of this I installed also VLC player to extract images from video clips. We will see it later in action. So when the framework is working, then we can download the code lab. And we will also need for the training device, the Android device. I use ZebraTC51. Also, we are going to need 6 other devices, which will be the objects. They should have a bit different form factor, and we also will need the PC for training. And very, very important thing is here the input data for our model. You will also need at least 300 images per device. They should be showing the device from possible different perspectives, angles, background colors, light conditions to train general model and prevent so-called overfitting. And then when training is done, we can take the model which we trained, and then we can push it to the application, to the mobile application, and then we need this Android application which is implementing this TensorFlow model. this application should take images using the camera on device, and then it will perform the classification. As an output, we should then display a classification probability. We will also need the same Zebra Android device, like TC51, to run this TensorFlow application, and of course these 6 Zebra devices which were used before for recognition to test it. Here down you can see this ZebraTC51, how it looks like, and in the second image there is a TC51 with this TensorFlow application running, and it's actually doing now the classification of the other device, which is the TC70. As I mentioned, I need these 6 different Zebra devices. Here you have the images of them. They are ET51, DS68, DS36, MC91, TC70, and TC8000. I've chosen them because they have slightly different form factors, what would make easier for classification. And however, as I mentioned, I registered the video clips of these different devices, and I tried to do it on 6 different backgrounds to check how clever the model can be when suddenly, for example, the background color changes. Also images, they will be taken from the different angles and the different light conditions. This should improve the model, giving more data to the system, and make this model a bit more general, probably preventing well from the overfitting. As you can see, I use images which I'm going to extract from this short video clips. And here is the example of one video clip. It is TC70 taken on a blue background. I have to mention it takes about 12 seconds, and I made this for all 6 devices on 6 different colors. It means I've produced 36 short 12-second videos like this. TensorFlow Code Lab, which I followed, is expecting a certain structure of the data of the images. So this is how it should look like. You should create the subfolders with the name of the object, and inside of each folder you should load all your possible pictures, where you could register or you could get from internet. It is important also that they are different and that they are taken from a different perspective. And here is what is needed to extract images from video clips. We will definitely use for it VLC player, where we have to change some settings and then open the file in VLC, and the program will automatically take some of the frames and put it into the folder which we will define. So when you open VLC Media Player, you have to go to Tools, Preferences, and in Preferences, Show Settings All, and then you have to go to Filters, and in Filters you have to activate the option Scene Video Filter. As soon as it is done, you have to go again to Filters, and then to the menu Scene Filter, and then choose your option. Very important option is the recording ratio, which I've chosen to be 5. It means I want the program to take every 5th frames from the video. So if I register the video with 20 frames per second, every 5th will be taken. So per second I will get 4 pictures, which will be afterwards copy it to the directory path which I defined here. Important also is the image format, which should be JPEG, because the TensorFlow is accepting this format. And then we go to Media, Open File, and choose our video, which we defined before. It was TC70 green. We open it and we can see that system is the program is taking every 5 frames, taking it out of the video, and then copying into my directory which I defined before. We have also to check the quality of obtained images, and if they are really copied to the folder, and maybe delete the bad ones. So if we have a file structure like this, with subfolders and with all images inside of them, we can proceed to the next step, which will be training of the network, of the model. But how will it work? So we are going to feed these images to the network, which you can see on this diagram. It is called the Google Net, and it is basically a structure which will train our network. You can see that this structure uses different methods and techniques to extract important features, key features of our images, and it includes several convolutions, pooling, max pooling, dropouts, and in the last layer there is a layer which is called softmax, and this algorithm will assess the probability of the classified objects. Important things to know is that we are not going to train all this network, all this model. We will focus on the last layer, which is softmax algorithm. For more details concerning this network, please go to the original publication, going deeper with convolution. The link is attached. So when we have already prepared these images and we clone the code from CodeLab of TensorFlow for Poets, we may start to retrain the model using these new images. And when it is done, we will look at this model. We will optimize it a bit to fit to the mobile use. So we will try to make it smaller and faster. So the hardware with the Android application can work with this. And then we transfer it to the Android application and test it on the ZebraTC51. And so now finally it's time to demo. You can see here that we use the retrain.py, so it's a Python script doing the job. You don't have to understand what is inside. What is important is that you understand that this script consumes parameters like a model type. We're going to use a model called inception v3. You also need to define path for input and output, and also so-called training steps. You can see here that we defined this folder, different background zebra, where we put all our images, and also that I may go here for 500 steps. but I'm going to change it. Instead of 500, I will choose the 4000, which is the maximum number defined here. So I will just delete these parameters, and then it will assume that it is 4000 iteration. What is this iteration doing? Each iteration chooses 10 images at random from the training set. From these images, and then it finds so-called bottlenecks from the cache. They are pre-trained constant, and then feeds them into the final layer to get predictions, and those predictions are then compared against the actual values, actual labels, to update the final layers weights through so-called backpropagation process. So here I'm going to start the script, having changed in deleting these parameters, how many training steps, to have it 4000. As you can see, script starts to work. It is defining so-called bottlenecks. As soon as they are defined, 4000 bottlenecks files were created, and then it will start to do the iterations. You can see that the first training accuracy is 50%. Then it is going very fast to 100. You can see also so-called cross entropy, who is falling down gradually. This 4000 steps is going to take about 10 minutes, so I'm to pause it until it is done. As you can see, we are approaching to 4000 steps. It will be soon finished. And as soon as it is done, we are going to visualize this process of training which we just done using TensorBoard. This TensorBoard code is implemented in this code lab. So basically, I will have to just write one command to run it. So it is the web application. So I have to open the web browser, and you can see that the accuracy basically was almost 100% after first 500 iterations. So it was probably not necessary to do all the 4000 iterations. You can see also cross entropy. Okay, we could say 1000 iteration would be enough, because then the gain was not that much anymore. We should also check if our job was properly done. We should go to our folder which we defined for the output as output folder, and check if two files has been created. As you can see, 1851, so 4 minutes ago, I've created the graph, which is 85 megabyte, and I have automatically also created the labels. And if you can see, the labels are exactly the names of my subfolders where we put images. As we could see, the graph which has been created is quite big. So to reduce the footprint of this model, we will have to get rid of any operations which are not supported on the mobile or not needed for the chosen model. In the lab code, we get the script which is doing it for us. So I'm going to run this, but first I will close my my tensor board. It will not take that long, and as soon as it is finished, we should see a new file which has been created. It should take about half a minute to go. Okay, when I refresh, I will see that my optimized graph is there. It's still quite big, but we will see it has much more air inside, so we will be able to zip it much better. So having done this, we will basically now quantize the network weights. So we will have a lot of repetitions, and this will reduce a little bit the precision, but still the model can be compressed in size very significantly. And this is, of course, very important for our mobile application. We have also a script will do it for us. It's also not going to take a long time, and we will be good. So it is done. I will refresh. And we have our rounded graph from 7 p.m. So we are good with the training. So now we are going to review our Android application, which is copied also from the code lab. You can see that in the main folder you have subfolder called Android, and in Android you have again subfolder called assets, and in the assets you have to swap the existing files, retrain labels txt which we saw already been created, and our last rounded graph. And having done this, we can start our Android Studio, import the project, and then compile it or recompile it for our device. I will go here and make a rebuild the project. It's going to take a few seconds, maybe up to 20, and then the APK will be created, and I will be ready to push this application to my device. I'm going to use remote desktop application to see what is going on the device. And now I'm going to run it on my device. I've chosen ADB, I've chosen my device, so I'm going to install it on the device. It takes some time, and soon the application soon we should have the installation screen asking for the permission to install this application on the device. Yes, so it's in German. Yes, I agree. I also agree that the photos, that the application will have access to my photos, and I'm done with the installing. So now when the application is working, we should try to test it. So we are going to find where our application is installed, and we are going to run it. I've prepared all 6 devices. Now you can see we expect here DS3606. It's 99% sure, the application, that it is DS3606, which is quite a good result. Then we move camera and the device to another device, to TC8000. Here our application have near 94 to 97% or 92, but it's definitely sure that this is this device. Then we go to 90 and 91, and it takes a little bit time. I shouldn't see the other devices. Okay, so we are also more than 90% sure that it is 90,000 family. Then we go again to the 4th device, which is DS6878. You can see it is also 96-98% of the accuracy. And then we go to TC70, and application is telling us it is TC70 with more than 90% 90 accuracy. And in last we go to ET8050, and the application should decode that it is A8050 85X with 98%. Now we can also check what is the application doing when it sees 2 devices. We didn't program it for that, but we can see that it is telling us, okay, ET55 is there, TC70 it is also there, so it is somehow giving the probability for 2 devices. Also, when we put 2 another devices, application will see TC70 and DS6878. Yes, so if we have another 2 devices, it should see now MC90 and TC80. So it is somehow giving quite a good results in recognition.